Why did the greeting card come after your birthday? Postulate. Get it? It's late. Postulate, postulate. So we'll be talking about some postulates today, side, 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 and side, angle, side, triangle, congruence postulates. So let's say I give you a triangle with 3 sides, 6, 7, and 10 units. Can you actually, first of all, make a triangle? So let's test that. Is 10 less than 6 plus 7? We always remember we take the longest side and compare it to the other two, and the longest side compared to the other two must be shorter because it's always straight to go in shorter to go in a straight segment. So yes, I can make a triangle with rods of length 6, 7, and 10 units. So here I have a little applet where we can explore. I've got 6, 7, and 10 units. And what are the different ways I can make a triangle? So you can see here, this is 6. And the reason you're seeing the circle shapes is that this point is always going to be 6 away from point A. Well, that's going to make a circle. So C1, I'm going to try and move it closer, and I can kind of guess where I need to bring it over here. C2 is the same way. Its circle's a little bigger. It can go 7. So we're going to try and get it closer and closer. And you can see that when I have them both meet right there, I create a triangle of 41 degrees, 105 degrees, and 34 degrees. Now, I can actually move these down further, and you're like, well, maybe I could make a different triangle. Let's see. It's actually the same triangle. It's the same angles, the same sides. So they're 2 congruent triangles. So if I'm given 3 side lengths that I'm able to make a triangle from, I can only make one triangle. So the side, side, side postulate says that if all 3 sides are known, there's only one way to make the triangle, which means if we're giving 2 different people a set of matching sides, their triangles will always be congruent. So the way I like to write this is if you know one segment's congruent to another and the other one's congruent and then the other ones are congruent. So these are showing 3 segments are congruent. Then you know both triangles are congruent. Using the reason if each side of one triangle is congruent to the corresponding side of the other triangle, then the 2 triangles are congruent. So here I have an example. It's a little bit challenging. Which triangle is congruent to triangle HEG using side, side, side? Well, one of the interesting things is that I can tell I've got these 2 match, these 2 match, those 2 match. So I need a way to get a third side that's congruent. Well, believe it or not, the reflexive property of congruence right there says something is congruent to itself. So I can actually say HG is congruent to HG. Now that I did that, I have a triangle here, G, and is congruent to this angle. See how it matches? It's between 3 and 2 and 3 and 2. I can also say angle EHG is congruent to angle GHF. So you can see that these 2 correspond. And then finally, these 2 angles, angle E and angle HFG, are congruent. So HEG, now that I have my angle congruences in there, if I go from 2 to 3 to 1, I want to go from 2 to 3 to 1. So HFG, that is my congruent statement. So when you're looking at your individual practice, go ahead and look for any sides that are shared between triangles, and those can be marked congruent to themselves. So there are also, besides the reflexive property, which I'll show again, there are some really helpful theorems and postulates that you'll be using for side, side, side. So you'll be using them to show sides are congruent or angles are congruent. For side, 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 we're mostly looking at showing that sides are congruent. So a segment, if I have a segment shared by 2 triangles, that's what we were just talking about. That's a reflexive property of congruence. Something is always congruent to itself. If I tell you something is the midpoint of a segment, that also creates a congruent segments by the definition of a midpoint. If I say a segment is a bisector of another segment, that is chopping that segment in half. So they create congruent segments, and that's the definition of a bisector. Same thing for a perpendicular bisector. It also creates congruent segments. So in this example, we're going to do a proof, and I gave you a parallelogram ABCD, and that's given. Now we're going to say that AB is congruent to CD. Notice how I make the markings. You should be making the markings on your proofs. And the reason I can say that, well, a parallelogram, opposite sides are congruent. I can also say the same for AD and BC. They are both congruent for the same reason. Now I'm going to add, I need triangle ABC, so I'm missing this side. Let me add it in. And you can see it's shared between the top triangle and the bottom triangle. Well, it's going to be congruent to itself by the reflexive property of congruence. Now I have 3 sets of matching sides that are congruent on both triangles. So I can use the side, side, side congruence postulate to show that the 2 triangles are congruent. So some things to reflect upon. How were you able to find this 3rd set of matching sides in the example and individual practice? What are some different ways to show that sides are congruent? Look at the helpful theorems and proofs there. Theorems and postulates. And how should you be marking the image as you work through the proof? You need to be putting down congruent marks.